Hello everyone. The topic I am going to take is about calorific value and analysis of coal, and it is from the unit fuels and combustion. Calorific value. Calorific value of a fuel is the total quantity of heat liberated when a unit mass or volume of the fuel is burnt completely. Units of heat. Calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade, which is 15 to 16 degrees Celsius. Kilocalorie is equal to 1000 calories. It may be defined as quantity of heat required to raise the temperature of 1 kilogram of water through 1 degree centigrade. Thus, 1 kilocals is equal to 1000 cals BTU, which is British thermal unit. It is defined as the quantity of the heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit, which is 60 to 61 degree Fahrenheit. This is the English system unit. 1 BTU is equal to 252 cals, which is 0.252 kilocals, which is 1 kilocalorie is equal to 3.968 BTU, which is about calorific value. Then higher or gross calorific value, which is also known as HCV. Using all fuels which contain some hydrogen, and when the calorific value of the hydrogen containing fuel is determined experimentally, the hydrogen is converted into steam. If the products of combustion are condensed to the room temperature, which is 15 degrees Celsius or 60 degree Fahrenheit, the latent heat of condensation of steam also gets included in the measured heat, which is then called higher or gross calorific value. So, gross or higher calorific value (HCV), it is the total amount of heat produced when unit mass per volume of the fuel has been burnt completely and the products of combustion have been cooled to room temperature, that is 15 degrees Celsius or 16 degree Fahrenheit. Then about LCV, which is also known as lower or net calorific value. In actual use of any fuel, the water vapor and moisture etc. are not condensed and escape as such along with hot combustion gases. Hence, a lesser amount of heat is available. So, the net or lower calorific value LCV, it is the net heat produced when unit mass or volume of the fuel is burnt completely and the products are permitted to escape. Net calorific value is equal to gross calorific value minus latent heat of condensation of water vapor produced, which is equal to GCV minus mass of hydrogen per unit weight of the fuel burnt into 9 into latent heat of condensation of water vapor. So, the carbon compounds have been used for many centuries as source of heat and energy. Dulong's formula. Dulong's formula for calorific value from the chemical composition of fuel is HCV is equal to 1 by 100 into 8080 C plus 34500 into bracket H minus O by 8 plus 2240 S kilocals per kg, where CHO and S are the percentages of carbon, hydrogen, oxygen and sulfur in the fuel respectively. In this formula, oxygen is assumed to be present in combination with hydrogen as water, and LCV is equal to HCV minus 9H divided by 100 into 587 kilocals per kg, which is equal to HCV minus 0.09H into 587 kilocals per kg. This is based on the fact that 1 part of hydrogen by mass gives 9 parts of water and latent heat of steam is 587 kilocals per kilogram. Analysis of coal. In order to assess the quality of coal, the following two types of analysis are made: proximity analysis and ultimate analysis. In proximity analysis, it includes the determination of moisture, volatile matter, ash, and fixed carbon. This gives quick and valuable information regarding commercial classification and determination of suitability for a particular industrial use. In ultimate analysis, it includes the determination of carbon, hydrogen, nitrogen, sulfur, and oxygen in coal. Since it is used for the determination of elements present in coal, it is also called as elemental analysis. This analysis gives exact results and are useful in calculating the calorific value of coal using Dulong's formula. Proximate analysis. It is used to measure moisture, and how it is measured for moisture is that about 1 gram of finely powdered air dried coal sample is weighed in a crucible. Then it is placed in an electric hot air oven at 105 to 110 degrees Celsius. This crucible is then is allowed to remain for 1 hour and then taken out, which is then cooled in a desiccator and weighed. The weight loss is then reported as moisture content. The percentage of moisture is equal to loss in weight by 100 gram weight of coal taken into 100. Volatile matter. The dried sample of coal left in crucible, it is then covered with lid and it is placed in an electric furnace or a muffle furnace, which is maintained at a heat of 1000 degrees Celsius. This crucible is then taken out of the oven after 7 minutes of heating. It is first cooled in air, then inside a desiccator, and then weighed again. The loss in weight it is reported as volatile matter on percentage basis. The percentage of volatile matter it is measured as loss in weight due to removal of volatile matter divided by weight of coal sample taken into 100. Then measuring ash and fixed carbon. For measuring ash content, the residual coal in the crucible is then heated without lid in a muffle furnace at 700 degree plus or minus 50 degrees Celsius for half an hour. Then the crucible is taken out, cooled first in air and then desiccated and weighed. And it is repeated continuously till a constant weight is obtained. The residual it is also reported as a percentage basis where the percentage of ash is equal to weight of ash by weight of coal taken into 100%. In fixed carbon, the percentage of fixed carbon is equal to 100 minus percentage of moisture plus volatile matter plus ash. In high percentage of removed carbon is desirable. Now, then the importance of proximate analysis. It provides the following valuable informations in assessing the quality of coal. First, in moisture lowers the effective calorific value of coal. Moreover, it quenches the fire in the furnace. Hence, lesser the moisture content, the better the quality of coal. However, presence of moisture up to 10% it produces a more uniform fuel bed and less of fly ash. Then volatile matter. A higher volatile matter containing coal burns with a longer flame, high smoke and a low calorific value. Hence, lesser the volatile matter, the better the rank of the coal. Higher volatile content in coal is undesirable. Similarly, others are also similarly for ash and fixed carbon, it's measured. Then about the next slide, it's about ultimate analysis, which we will see in next class.